Let's talk more about input-output functions. We have already used print and input functions. Before we start discussing the use of databases, I would like to present you the ways you can interact with files. Because for a very basic database, you don't really need to have any specialized database or database server, as you can have your data written into the file. One common way of representing data in files is called comma-separated value file format. An example of such file format can be written using the following string variable. Please note that triple quoted strings in Python are used to define multi-line string constants. This way we have multiple lines and every line will contain one record. And let's say that we have record 1 which says John and then Smith and then age 45. Then we'll have record 2 which is Donald Simpson age 54. And then we will have Mary Winston at the age of 35. And we want to read this information. So here every line represents one record, and every value that is separated by a comma represents one of the elements, in our case every so-called column of data. So the first value in every line will be representing the ID of the record, and then the second column is representing the name of that record, and then surname of that record, and then age. How do we process this data? One very simple way in Python is to use a little bit of string operations, so we can take comma-separated value format, and since this is a string, it will have a method, a function that is assigned to the particular object that is called split, and we can split a line or a string using an arbitrary character or a sequence of characters. In this case, we're going to split it by character /n, which is representing the new line character, and we will save this as variable lines. And now if we run this code, you can see that the result is a list that contains 3 lines which are correctly separated. Now for every line, we will need to do the following operation. First, we need to define the rows dictionary that will contain our processed data. And for every line in lines, we will need to do line, split, and then we will split it by comma. And this will create a list that will contain individual values for columns. And then let's break them one at a time first and print them out. Now we have 3 lists printed out, but this representation is not very useful, so let's have something more structured. To do that, we can use what is called unpacking of lists. We take a single list that contains different elements, and we assign different elements into different variables in order of their appearance in the list. In our case, we will use variables names as :id, :name, :surname, and :age. Now what's left for us is to just format this into a proper dictionary. So we use call_id, and we will first convert it into an integer. We have done that before with int function. And then we will assign that ID as a key for our dictionary. And then we will format our new record. The new record will also be a dictionary on its own, and it will contain the following keys: name, surname, and age. And we will also need to use integer conversion to convert string into an integer value for age. So it has done something, and we can now run rows, and we can see that we have a dictionary that contains different keys, 1, 2, 3, which are our corresponding IDs of the elements that we have read from the file. And then we have name, surname, and age for each of them. So in this case, let's check ID 1, and let's try to get its name individually. We are referencing the rows dictionary by key 1, and then the resulting dictionary by key name. And we get John. Very nice. Now this will work for very simple formatted comma-separated files, but in some cases you need a slightly more advanced approach. And for that purpose in Python there is an existing standard library that will do parsing of actual CSV files for you. To do that, first let's talk about how we can actually open and read any data from file, because right now we have the input provided as a constant string. Let's say we have a file, and let's create one. Let's copy the contents that we are going to use there. And we are going to use terminal and touch to create a file. And let's name it input.csv and open it in editor. Now we can copy paste the contents of the file in, and we can save it. Now we close this file. And to read data from the file inside Python, we will use a standard function that is provided by Python that is named open. And the arguments for that function are very simple. So first we type open, and then we need to provide file name. And because file is located in the same folder as our script, it is enough for us to just write this path. In other cases, you might need to write more complex paths and maybe provide absolute path, relative path, or maybe in some cases, if you want correct cross-platform location handling, then use pathlib. Either way, this will be explained in more detail in practical exercises. So we're going to open an input.csv, and the second argument that we need to provide is the type of operation. So we want to open this file for reading, which means that we need to write R. There are two ways to open a file. You can open a file for reading or for writing, and you can also handle this file as a text file or as a binary file. In this case, we're using this file as a text file for reading. If we were to use it for reading as binary, then we would have added B after the R. You can also look up the description of this function in the documentation for Python. So this is a built-in function, and the arguments are listed there. There are also other modes than reading and writing, so in order to understand how to use that, you really want to check the documentation. But in a very simple case, in most cases actually, you will need to just read the file as input, or write out your processed data. So let's execute this line. And this function returns what is called a file handler, and it saves it into variable f. This is a reference to the file within the operating system, which in this case Python is represented by this object f. We don't really need to care about that much, but there is one important function of that object that we care about, and that is named read. The read will read the values from that file and return them as a string. And as you can see, we have received the content that is very similar to our original CSV data variable, with the only major difference that at the very end of this file we have additional /n character. Let's convert our existing code into a parse CSV function so that we can reuse it. And let's have one argument for it, named data, and let's have it return the dictionary. And now we need to also split this data into actual lines. And let's define this function. And now we can apply this function to the data that we have loaded from the file and execute. And as you can see, it started processing things, and it processed 3 lines correctly, but then finally it got to this new line that has been created by this rouge /n character at the very end, and it ended up with an error. Not enough values to unpack. Expected 4, got 1. To avoid this problem, we can simply check for the amount of values that we get from the line.split. And we can first save that into a new variable. Let's name it vals. And then we can check for length of that list using len function. And we need to check that length of vals is at least 4. And in this case, we can unpack values. Otherwise, we want to skip execution of the rest of this loop. Let's redefine the function and let's execute it. And now it has been processed successfully. So we can open the file, read its whole contents as a single string, and then we can execute our parse CSV function to get the actual dictionary with values. Now the problem is that this function is not really universal. This one is only good for this particular dictionary because we know and we use the knowledge about the dictionary, how these columns are structured, and thus it's not a universal solution. To have a more universal approach, we can use header line or header row of that file. So let's open the file again with text editor and provide some names. So let's type ID, name, surname, and then age. And let's save it. Now, of course, we will not be able to just read this file and execute our function because the first line contains invalid data. But we can now use this first line as a header for the rest of our code. And we will first skip it here in parsing, and instead we can store values from the lines 0 into headers. Now we can use this newly acquired structure to create our dictionary. So instead of unpacking these values and actually creating any dictionary like this, we will do it the other way. We will first create a new empty dictionary. Let's call it new val. And then we will loop through the vals. But we will use one utility function from functional programming that is called zip. And we will type for :name and value in, and we will use function zip, and we will zip together headers from which we will source call names, and we will zip vals. This construct will effectively iterate together at the same time both this list that contains headers and the list that contains values. And now we can use this information to assign values to our empty dictionary. And finally, we want to assign this dictionary into our rows. To do that, we will use the ID key to get the identity of the record, and then we will assign into rows the values that we get from this ID, and we assign new val on its own. Okay, now this is a very universal function. If we run it here now, of course after reloading the file, let's see what file data contains. Okay, yes, that's because we forgot to split the line 0 into a list. Now if we run it, we get the expected result. So first of all, as you can see, now all variables are strings again because we don't do any data conversions, and our keys are now also strings. To implement data conversion, we will need to make slightly more sophisticated data structure in the header of that CSV file, but in most cases you really don't need to do that because you can do conversion of values of individual columns into appropriate data types after you have loaded that file. One other drawback of this approach is that we are now basically bound to a very strict format that we have invented, and any deviation from that format, for example use of semicolons instead of commas, will cause our function to be broken. To avoid that, we can use a standard Python library that is provided for us that enables reading of different formats of CSV files, and we can select the exact format by providing some arguments to that function. To handle these CSV files in this way, we will use the CSV library. So we will import it, and in order to process the file in such way, we will need to open it again, and we will need to create a CSV reader out of that file. Now we can use this reader object and just read the values. And as you can see, it correctly separated all our rows into correctly demarcated lists. And in order to use this with our function, we will need to adapt it a little bit. Let's name it parse CSV _2. And let's, instead of data, provide lines directly. And we will also have no need to do splitting anymore because lines already contains the split values. And this is a duplicate function. Other than that, we also need to convert these lines because in this case it will be a generator object. Let's make sure that we have a proper list first so that we can iterate it freely. Now we can use this parse CSV2 function to parse the values returned by our reader. And as you can see, it returns data as we expected. And of course, if you want to actually modify the format of input CSV file, you can just supply additional arguments to this call. To look up for potential values, you can go to Python documentation and look up CSV module. And as you can see, it accepts delimiter and quote character as optional arguments. Later, I will also present you a library that is called pandas. The pandas library allows you to read CSV files that have a header line as the first line of their CSV file. And then pandas will automatically create dictionary in the same way as we did right now manually. Pandas will do that for you. One other important question: how do we get these CSV files? Because this doesn't sound like a very common format. But for example, if you have data in Excel, or in case of Linux in some open office suite, for example LibreOffice Calc, you can use this table and you can type data here. And as you have this table, you can press File, Save As, and select Text CSV as your output format, and save it there. And we will use text CSV format for this file. It will also ask you how do you want to specify the field delimiter and string delimiter for this file, and we will use it as is and press OK. And now we have this second open CSV file, which we can open with text editor to see what's inside. And you can see that it looks very similar to what we have. You will also be able to export CSV data from databases. Most of them will provide export directly, or get this information from external resources, such as different APIs. I will not give you any examples right now, but we will get to that. Two other popular formats for storing data in files are JSON, especially popular when you are using JavaScript, and YAML. We're not going to talk about them right now, but later in practical exercises you will see how to use these files and the data structures that are formatted in JSON or YAML. Finally, we need to talk about things that might go wrong in programming. For example, here we assume that this CSV file exists on the disk, but let's say we have a typo in our code, or in some case you will format this file name from variables and you mistype something and somewhere add extra units or just miss a file. What will happen? Let's change the name to some non-existent file and run this code. And as you can see, the Python now indicates file not found error. In case of Jupyter Notebook, this printed message is basically the only consequence, and you will not be able to just continue executing the cell. In case of a real problem, an handled exception will result in termination of your program. The exception is an indication that something has gone wrong, and most exceptions are implemented in such ways that they are actually recoverable. So even though we don't have this file, we might want to handle the missing file situation by letting user know that the file is missing and that maybe user should do something about that, but without terminating the program, and to give user opportunity to select another file, for example. To handle exceptions, we are going to use try except syntax. And try except syntax is as follows. So let's wrap our call to parse CSV, or actually to open already here. Try colon and then add one indentation level and type except colon at the end. Then between except and colon we will also type the expected exception type, and we will use exception as expected type, and this is the broadest possible exception class. Every single other class is inherited from it, and we will talk about custom exceptions and inheritance when we are going to talk about object-oriented programming in Python. But here we have exception and we save it into variable e, and for that we use the syntax as e. And now we can just print, for example, this variable and see what's going on. So now the program is executed correctly, even though we have an error there. And now when we try to get this file, we just get exception, and this exception causes the block of except to be executed. And within that block, we have variable e that contains our exception. And when we print that variable, we actually get this message, error number 2, no such file or directory, input3.csv. The unfortunate outcome of the approach when we use the broadest exception is that if instead of opening file, we were trying to, for example, make a division by 0, we would have getting the same block triggered by another type of exception. In this case, this is division by 0 exception. For that purpose, you usually want to have multiple different exception blocks that will be located one after another, and they will be checked starting from the first to the last. And if the error message matches the class of the exception that is handled by this block, then this block will be executed and the rest will not be. Let's for a moment have a look how the exception for division by 0 looks like. Here you can see 0 division error, and this is the class name that we want to handle. For example, if we paste it here instead of exception, we will now see this print message executed, and 2 other exception print messages are not executed. If we remove this division by 0, on the other hand, and execute this again, we can see that this block is not executed, although we have an exception, and this exception will be of the file not found type. And now, as you can see, we have 2 individual blocks for 2 different potential errors that might occur within this block. And then we have a global catch-all block. Let's make a simple user input driven application. So let's use while true, and then let's get file name from user, and then let's shift this into indented block inside the while loop, and let's open file name that user entered. And if this results in a success, we want to break out of this loop. And let's run this. Now we have a prompt, and let's try typing something. And as you can see, there is no such file DSF, but if we will type a proper file name, it will be correctly opened. However, here we are missing printing of the actual dictionary that results from parse CSV. And now we can see that the results are as we would expect. The program correctly loads the files that are specified by the file name that user has entered, and in case of error, it just tries to ask for another name. Now in some cases, as for example this with zero division error, you don't want to let our user to continue the execution of the program, and you might re-raise the exception by running the raise without any arguments at the very end of the except block. And if we do it like that, well, nothing will happen right now. Let's add an error here. Let's divide by 0, and enter a valid file name. And as you can see, division by 0 error has been reached. And even though we have entered the except block and printed our message, we still got this standard system message because we have re-raised the same exception that have been entered. This is helpful in some cases when you want to do something about the exceptions, but you still want them to be handled by external code. For example, if you're writing a library or a function that will be used by someone else.